Okay, once we have our graph, whether a dot plot or a histogram or whatever, next thing we want to do is talk about the shape of a distribution. And when I'm talking about describing a shape, I imagine what we do is kind of imagine having your eyes closed and drawing the outline of the shape, outline of your graph. That would be called the distribution. When describing the shape of a distribution, you should be able to answer the following three questions. First, how many peaks, if any, are present? And I mean peaks that are beyond just random chance. Is the distribution symmetric or skewed? Is it symmetric or is it skewed? And are there any unusual features in the distribution, such as outliers? Well, first off, how many peaks, if any, are present? Now, if a distribution has one main peak, we call that unimodal. And for this graph here, unimodal, often the mean, median, and mode are all the same. So unimodal is kind of the ideal type of graph. This is what we like to see. Because, at that point, it doesn't matter. When we have two modes, two peaks, we call that bimodal. So this example here, the modes, there's two different modes. The median this still looks more or less that evened out, left and right look about the same. So the mean and median is still in the middle, but you can see the modes are spread out. A distribution with no peaks and shaped more or less like a rectangle is called uniform. So there really isn't a mode to talk about, but in a uniform distribution, the mean and median are about the same. Now, the second thing we look at is symmetry. Is a unimodal distribution symmetric or is it skewed? Well, unimodal distribution is symmetric if you can fold the distribution along a vertical line through somewhere around the middle and have the edges match up pretty closely. Now, in the real world, you're never going to get exact. So the best we can do is just does it look more or less like the left and right sides are the same. When one side, we call the tails, when one tail tends to be longer than the other tail, we call that skewed. So if one tail stretches out farther than the other, the histogram is said to be skewed to the side of the longer tail. So this graph here on the left is skewed left. This is comparing age with the number of female cardiac patients. What it's basically saying, is that most female cardiac patients are rather older. There's not a lot of young female cardiac patients. Now, the second one, skewed right, in terms of the charges, a few people were charged quite a bit, some not so much. So this would be skewed right. So symmetric unimodal graphs are the ideal. That's what we like to see, is symmetric and unimodal. Though skewed graphs can also work provided the sample size is large enough. As we'll see later, the more skewed the graph is, the larger the sample size is needed to be. Alright, and the last thing we want to concern ourselves with are outliers. So are there any unusual features in distribution such as outliers? Sometimes it's the unusual features that tell us something interesting or exciting about the data. You should always mention any stragglers or outliers that stand off away from the body of the distribution. For one thing, outliers have a big impact on means and standard deviations. And another thing is that it could be an indication of a typo or some error in your data set, or it could just be something interesting. So often, not always, outliers are due to mistakes, such as writing 5,000 instead of 50. Other outliers may indicate that something unusual is happening. So if you see an outlier, proceed carefully. Alright, so let's look at a couple of these. What can be said about each graph? Well, part A looks symmetric, unimodal. This is the ideal type of graph for us. So unimodal, symmetric. Part B, all the bars are more or less the same. There's some slight differences. That looks to be just random chance. So this is uniform. For this third graph, is definitely the left side is much shorter than the right side. And I'm judging from the height, from the tallest bar. So we call that skewed right. For D, you see here it looks bimodal. There are two different peaks. And the peaks don't have to be exactly the same height, but I mean there are two clear peaks that are not just random chance. And then finally, this last graph looks pretty unimodal symmetric, except that there's an outlier right here. So unimodal symmetric except for an outlier on the right.